I was still opening the recording. So just remind me to send this after the class. So let's start
Alright.
with implicit, and then we'll go to integration by marking that one, the one that by trigonometric. Is it trigonometric substitution that we did? Implicit with that question that you sent. You can see the screen. Eh?
Yeah.
So they wanted you to differentiate this one. So you will just say d over dx both sides. That's the first step. X cubed plus y cubed d over dx 18xy. And then you differentiate this one, you get 3x squared plus differentiate that one, it's 3y squared dy over dx. Then you'll get 18. You can take out 18 as your constant. Differentiate using product rule, you'll have y x times dy over dx.
Xi freezini u vona ke nchumu.
On the left, 3 plus 3y squared. I will check again. I'm sure it's your network. Plus 18x dy over dx. You can still see the screen. By stream, then you'll just group the one that you've got dy over the x squared. Then we take out dy over the x in x minus 3x squared. Then y squared minus 18x. Are you able to see the screen? And these ones will cancel. This person logged out. And yes, I'm able to see the screen.
Imana, we are sure. I don't mean.
Yeah, but I'm able to see the screen.
Iman tlhelela ka link.
Okay, go back.
Hawa anishuboni.
And how about now?
Na sweswi.
Yeah, you have a network problem.
Yeah.
So I don't know. So what's the plan? Means we'll stop here. But I was done with the first one. But it's fine. You can log out. I'll try to record whatever I'll record.
Alright.
Means I'll be talking alone. It's fine. And number 2, x plus tan xy equal to, and say d over dx plus tan of xy equal to d over dx of 2. Then from here you just distribute d over dx of tan of xy. And this will be 0. Then this will give us 1 plus the derivative of tan will give us sec squared x times the derivative of x, which you know will be 1, plus sec squared y times dy over dx, and this will be 0. Then I can say 1 plus sec squared x, then this one will be 1 plus sec squared y dy over dx. And I'll take this 2 to the left. We'll have negative 1 minus sec squared x. Then I divide both sides by sec squared y by sec squared y. And then I'll be left with dy over dx being equal to negative 1 minus sec squared x over sec squared y. So that's it on this one. For implicit, we only had 2 questions, and then for logarithmic, I'll only do number 2. So I having, they were saying use logarithmic. They were saying use logarithmic, right, to find logarithmic differentiation to find the derivative of y being equal to x, the square root of x squared plus 1 over x plus 1 squared. So you're going to introduce ln, both sides. You introduce ln, square root of x squared plus 1, x plus 1 all squared. Then you say the ln of y is equal to the ln of x plus the ln of the root of x squared plus 1, then minus, since now we have a division there. So it will be minus the ln of x plus 1 squared. Then from here, you're going to do what? You're going to now introduce the derivative. So you'll introduce a over dx, right? Enabling y, introduce it also on the right. And this one will just be 1 over 2 because you'll bring down the half there using the logarithmic rules. Minus, and even this one will bring it 2 down. We'll have this. Then from there, you'll just differentiate ln y with respect to x. You'll get 1 over y times dy over dx being equal to the derivative of ln of x is 1 over x, 1 over 2. The derivative of this of ln of x squared plus 1 is going to give us 2x over x squared plus 1 minus 2, 1 over x plus 1. Then our answer will be dy over dx will be equal to multiply both sides by y, multiply by y. Then have y into 1 over x plus this 2 and that 2 will cancel. So we'll have x over x squared plus 1 minus 2 over x plus 1. So that's what we're having. And then we replace y with the original value of y. We know it was x square root of x squared plus 1 over x plus 1 squared. Then we have 1 over x plus x over x squared plus 1 minus 2 over x plus 1. So that will be the final answer. And I said, make sure that you replace the value of y because there is a mark for that one mark, right? Let's see, change page. This one is fine. So now we go to by parts. By use substitution, those ones you will do them. Parts. Integral of u dv is equal to uv minus the integral of dt. Then on number 1, and I said, you know, free to choose your u using the abbreviation here. And for logarithmic, I for inverse functions, A for algebra, T for trigonometric, E for exponential. And then now you are having this, the integral of the sine of 5x dx. So now you have to choose which one is going to be your u. So this is trigonometric, and then this one is an algebraic function square. So between trig and algebra, this one is that first. It's going to be our u. Then we know we're going to say let our u be equal to x squared. Then I find the u over the x will be the 2x, and then we make the x subject of the formula, right? Will be will be the u over 2x. Our dv. So if this one is our u, this one, the rest v is equal to this sine. Interpret both sides. then I integrate. Then the integral of dv will simply be v. The integral of sine of -1/5 the cosine of 5x. If I differentiate this one, it must give me back that one. So cosine 5x is simply negative sine of 5x times 5 multiplied by -1/5. You will realize that we get sine of 5x. So that answer is correct. So we know the value of v, we know the value of u. So now the only thing left is for us to say the integral of x squared sine 5x dx will be equal to its x squared, the value of v, 5 cosine of 5x minus the integral of v, it's -1/5 cosine du. So du, we can get it here, right? This one. So we must make du subject of the formula, not here. So, but we'll get, if we do cross multiplication, we'll just get 2x dx. So you are going to put 2x dx there. And then this will be equal to x squared. Let's put the constant here, -1/5 x squared, the cosine of 5x minus, and then now we're having, this will be positive due to having this negative and this negative. And we'll have positive the integral of, and check out the constant of cosine of 5x. Here we have 5 cosine of 5x, and then times 2x dx. And we know that we do not know the integral of this. Now we're having -1/5 x squared cosine of 5x plus 1/5. That means here we'll have to integrate this one using by parts again. So we can say, I usually do this separately, right? I will solve this one separate. So I'll say from the integral of cosine 5x to x dx, let u be equal to 2x, then du over dx will be equal to 2, then du I know it will be 2 dx, then dv would be equal to the integral of cosine 5x dx, and then I integrate. This will be v equal to +1/5 the sine of 5x plus c. Right. So I know the value of v, I know the value of my u. So this implies that now we're having the integral of cosine of 5x times 2x dx. So this will be equal to the value of u, we just found it, it's 2x, and the value of b is 1/5 sine of 5x. So we'll just substitute. Our u is 2x. Our u is 2x multiplied by v, which is 1/5 sine of 5x, minus the integral of 1/5 v, which is this one, and du we discussed what is the u. The u, we said it's equal to, no, v it should be, oh, I need to substitute v du. I already substituted v, now I need the u. So I know it's 2 dx, right? So I know it's 2 dx, v 2 dx. Then I simplify. I'll 5x, the sine of 5x. When I simplify this one, then minus, and now I'm having that integral of 1 over 5 sine of 5x dx. So this is the answer, right? So this answer, I'm going to put it here. We must replace that here. So I'm gonna do that now and say we're still having the integral 1 sine of 5x dx, and we ended up so this one equal to negative 1 over 5. The rest of the stuff was negative 1 over x squared. I must take this and just copy everything here. And let's put that here. And now we know the integral of this one. To calculate it, this one is the one that we just got here. So I know 1 over 5 x squared, the cosine of 5x, plus 1 over 5, and then into 2 over 5 x, the sine of 5x, x minus 2. Let's just say minus 2 over 5 of sine x dx. Dx, right? And we know the integral of that 1 over. Then I can multiply this here. And sine of 5x minus 5 multiplied by 5, integral of 1 over 5, the cosine of 5x. C be our answer. Write it here. 2 over 25x sine of 5x minus 2 over 5 will be 2 over 25 multiplied by 1 over 5, it will be 2 over 25 times 5. It will give us 7, 8, 9. It will give us what? So I having 25 multiplied by 5 give us 125. It will be over 125. So that's it on that question. Then we move to integral by trigonometric substitution. So here we have got 3 cases, which I'm going to discuss now. Let me just check if this is the recording. Still recording. So now we've got 3 conditions here that you guys must know. Three. So here we're dealing with integrals of this form. Integrals involving the root of a squared plus or minus x squared, and also the root of x squared plus or minus a squared. So we're dealing with this kind of integrals. So when you have got the root of a squared on your integral equation minus x squared, we're going to let our x be equal to a sine u. Let me just use a different color. This we're going to let your x be a sine u. And you're going to, if you have got the root of a squared plus x squared, you let your x be equal to a, the tan of u. Then the root of x squared minus a squared, you just let your x be equal to a sec u. So the one that has got minus, you know it's for in between, it will be for sine, for the trigonometric sign. But if you have got plus there, you will have tan u. And then if you are starting with x squared, minus a squared, you will have sec u, the trigonometry sec u. So now let's do a question, right, that will help us with this. So let's say you are having this one, number 1, you are having the integral of the root of x squared minus 1 over x squared over x squared dx. So since you are having the form, so here we know that u substitution is not even going to work. So we know that this is in the form x squared minus a squared. So if we are having this, I said we're going to let our x be equal to a, the sec of u. So the question now is, what is a, right? So it means we must do the square of that one, because a must be squared. You must be having a squared there. So you're going to have the integral of the root of x squared minus 9 squared all over x squared dx. So, and the answer of this must be in terms of x. And so we're going to have a triangle at the end so that we can represent our trigonometric ratios, these ones. So now what we're going to do is we're going to say the integral, then when there is x, we will replace with our x will be 9 sec of u. Then this will be 9 sec of u all squared I'm having minus 9 squared all over x squared dx. So now it means we'll have to differentiate this one, right? The u, the x in terms of u, the x over the u will be equal to 9. The derivative of sec u will be sec of u tan u. Then the x will be equal to 9 sec u tan u du. Then you take this one. Let's take this one and copy it. So there is the x will replace with that. So now I know that I will be having the integral of the root of 81 sec squared u minus 81 over, I'm having x squared the x. So where there is the x, I'm gonna replace with a with 9 sec of u, the tan of u du. Just replace with that. And let's take this to the next page. And when you are here, right, on this step, it means we must also replace this x squared in terms of u. So how gonna get x squared? So we can replace x squared from this, right? We can just square both sides. So if we're squaring both sides, it means x squared, it will be 81 sec squared u. So we know we'll be having the integral of the root of, we take out 81, we have got sec squared u minus 1 all over, where there is x squared, it will be 81 sec squared u. Then we have this, we have 9 sec u tan u du. As you can see, these two will cancel, but here will be left with 1 sec u. Then you'll have the root of 9, the square root of, so this one is an identity, is tan squared u. Then all over, we have 81 sec u multiplied by, here we're having 9 tan u du. So if you check this 9 and this 9 will multiply one another, you'll have 81. Then this will give us what? It will give us the root of tan u squared will just give us tan of u, then over 81 sec of u multiplied by tan u du. Then these two will cancel. Then you'll be left with the integral of tan squared u over sec u du. So from here we know that we can change a tan squared u to its identity, which is sec squared u minus 1, and also have sec u du. And then what you're going to do here, you'll just divide these two together. You'll have sec of u minus 1 over sec of u du. Then you integrate sec u, you'll get the integral of sec u will be what? The integral of sec u, I say it's tan squared. If you differentiate this, you're not gonna get that. Let me just check what's the derivative of sec of u, because I forgot it. So the derivative of sec of u will give us, just check this one out. Let me just check that here. The derivative derivative of sec u. Oh no, not sec u. It's the ln of sec x plus tan x. So this was a proof. This one is the ln of sec u plus tan u. So that's what you're going to write here. Then this will be the ln of sec of u plus tan of u minus, this will just be minus the ln of sec of u, then plus c. So this one is our answer. So let me just copy it. So this is what we're having. This is our answer, but then we'll have to replace it with in terms of x. Let's just put this plus c. So let's just put this plus c. We'll put it here. So now we'll just draw the triangle, right? Remember we said our x was equal to, let's go back and check what was our x. Our x, we said it was a 9 sec of u. 9 sec of u, that was our x. So I must draw a triangle with that. 9 sec of. So we know that I can divide both sides here by 9 and 9. So this is x over 9 over sec u. So since sec u, its inverse is what? Its identity is this one, is cosine u. And you guys know that cosine u on a triangle is just adjacent over hypotenuse. Therefore, it means for sec u to be hypotenuse over adjacent. It will be the inverse, right? So this is how you draw your triangle. You just say you have that, then you can put your angle u here. By u is our angle, and then adjacent, our hypotenuse will be x. Then our adjacent will be 9. Put it there. And this one will be the square root of what? Of x squared minus 81. The opposite side. And then now the only thing left will be to replace that one. So our final answer will be the ln. So sec u is equal to x over 9 plus, then tan u will be opposite over adjacent. So you'll have the square root of x squared minus 81 over 9. Then you close minus the ln of x over 9. Because here you are having sec of u. So, and that's it. So now let's do the last part. One more example, right? Let me see what you guys give me here. So I'm just gonna do maybe one question for, okay, let me take this one for trigonometric integrals. So you are having the integral of, let's take this one, of cosine of 5x sine of 4x dx. So since this one is odd, we can see that this one is odd, right? You can apply case number 2 from your rules. It says when you've got an odd there, you'll just save one cosine factor. So we'll have 4x, you save that cosine factor with degree 1, then we have sine of 4x dx. Then this will be equal to the integral of so from here you'll say the integral of, you change this one to cosine squared x squared cosine x dx, and this will be the integral of 1 minus sine squared x squared cosine x. So this one sine x dx. So now if I decide to say let my u be sine of x, it will be an advantage because I'll be able to cancel that one, and the u over dx will be cosine x, and then dx will be du over cosine x. And then I come and replace this dx there. Then I'll have the integral of 1 minus sine is u squared sine x. Then we have du over cosine x. Then these two will cancel. Oh, and that sine x, it's our u. This is u. So we know that we can simplify this by having this now, u du. So we can simplify this part. It will give us the integral of 1 minus 2u squared plus u to exponent 4. Then with u du, this will be the integral of u minus 2u to exponent 3 plus u to exponent 5 du. Then the value of the integral of u will be u squared over 2 minus 2. The integral of that will be u 4 plus u 6 plus c. Then the value of u, we know it's sine x. So just replace everything there by sine x. So you are going to have sine x squared over 2 minus 2 sine x 4 over 4 plus sine x 6 over 6 plus c. So that will be our final answer for that one. So yeah, that's it. Then you guys can go and do this question under L'Hopital's. Let me just write it for you. It is not open. So now you're going to, you can just go and do this homework. So use L'Hopital's to find the following limits, right? Find the following limit. So you'll go and check. You can do this one, the limit as x approaches 0, 1 over x squared of cot x over x. Then 2, you can do the one whereby you have the limit as x approaches 0, x sine of 1 over x. Remember, the hint is to make everything a what? A fraction. Then you do your limit as x approaches a particular number. Yeah, and then with this one, for integral under trigonometric substitution, I'll just give you for number 2 because I did number 1. We have 1 over x squared, the root of x squared plus 1, okay, the x. So with this one, you know that, okay, you're going to let your x be equal to will be 1 tan of u, which is just tan of u. Then meaning you'll start like this. Where there is x, you'll say you just put tan u, then tan u squared plus 1. So, but I think this is very easy, right? You'll just have this squared u, then you'll remain with like u here. Yeah, and then you'll just change this one to its identity, which will be, yeah, so you'll continue from, so you'll change that one to its identity.